The hierarchical memory coherence system maintains consistency across distributed cache layers through a series of defined states and transition rules. Each cache line exists in one of 5 states: modified, exclusive, shared, invalid, or pending. The system operates without interruption across all processor nodes. State transitions are triggered by load operations, store operations, and explicit invalidation broadcasts from remote nodes. Modified state indicates that the current processor holds exclusive write access and the line contents differ from main memory. When a modified line is requested by another processor, the owning processor transitions the line to shared state and sends the current data to the requesting processor. Explicit flush operations force modified lines back to memory and transition them to exclusive state. No other processor may hold a copy while a line remains modified. Exclusive state represents a cache line where the current processor holds a copy that is consistent with main memory, and no other processor possesses the line. A processor may transition an exclusive line to modified by performing a store operation without broadcasting. If another processor requests the line while it is exclusive, it transitions to shared. Exclusive state eliminates the overhead of coherence messages for write operations that do not require shared access. Shared state indicates that multiple processors may hold valid copies of the cache line. All copies in shared state are consistent with main memory and with each other. A processor holding a shared line may read the data without further coherence traffic. To perform a write operation on a shared line, the processor must transition the line to modified state and invalidate all remote copies. This invalidation broadcast must complete before the write operation becomes visible. Invalid state signifies that the cache line contains stale data and must not be used for any operation. Lines transition to invalid when another processor writes to them, while they are in shared state, or when an explicit invalidation request is received. A processor may also invalidate lines locally to make room for new data during cache replacement. Invalid lines remain in the cache, but participate in no further coherence operations until they are fetched again. Pending state is a transient state entered when a coherence request has been issued, but the response has not yet arrived. Lines in pending state cannot be used for load or store operations. The coherence request must complete before the line transitions to its final state. Pending state duration is bounded by the coherence timeout interval, which is configurable on a per system basis. If a timeout occurs, the coherence request is retransmitted with exponential backoff. The coherence directory maintains tracking information for each cache line across all processors. The directory stores the state of each line and a list of processors that hold copies in shared state. Directory lookups occur synchronously during coherence operations. The directory itself is replicated across multiple memory controllers to avoid a single point of failure. Directory entries are updated atomically before acknowledgement is sent to requesting processors. Broadcast-based invalidation occurs when a processor transitions a line from shared to modified. The invalidation message is sent to all other processors in the system. Each receiving processor checks whether it holds a copy of the line. If a copy is found, it is immediately transitioned to invalid state. Processors acknowledge invalidation receipt within a bounded time window. The requesting processor waits for all acknowledgements before proceeding with the store operation. Read-exclusive requests are issued when a processor performs a load to a line in invalid state. The coherence system searches the directory to determine which processor holds the line in modified state, or whether it must be fetched from main memory. If the line is in modified state on another processor, that processor sends the data and transitions the line to shared on both processors. The read-exclusive request completes when the data arrives at the requesting processor. Coherence timeouts are measured in coherence clock cycles. The default timeout interval is configurable via the system configuration register coherence timeout cycles. Valid values range from 64 to 4096 cycles. When a timeout occurs, the coherence request is marked for retransmission. Retransmitted requests are sent with priority queuing to prevent starvation. The system maintains statistics on timeout frequency and retransmission patterns for performance analysis. Cache line size is fixed at 64 bytes throughout the system. Coherence is maintained at the granularity of entire cache lines. Partial writes do not affect remote copies. The coherence address space spans from 0x000000000000000000 to 0xFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFffffff in 64 byte aligned blocks. Address alignment is enforced by the cache controller. Unaligned access requests are rejected with a coherence alignment error exception. Write-back policy dictates that modified lines are written to memory only when they are evicted from the cache or when a flush operation is explicitly issued. The write-back occurs asynchronously to the store operation. During write-back, the line transitions from modified to exclusive. If another processor requests the line during write-back, the requester waits for the write-back to complete before receiving the data. False sharing detection is performed by monitoring coherence invalidation frequency on adjacent cache lines within the same cache block. If invalidation frequency exceeds a threshold, the system logs a false sharing event and records the affected address range. False sharing statistics are available via the Coherence Performance Counter interface. Software may access these counters through memory mapped I/O at base address 0x FFFF0000000000000 plus offset register values. Coherence exceptions are generated when protocol violations occur. Coherence state invalid is raised when an operation is attempted on a line in invalid state. Coherence timeout exceeded indicates that a coherence request did not complete within the configured timeout interval. Coherence deadlock detected signals that the coherence system has identified a circular wait condition. All exceptions trigger a system-wide coherence reset. Performance monitoring registers are accessible via the perf counter interface at base address 0x FFFF800 billion. Counter addresses are organized as perf counter base plus counter ID offset. Available counters include coherence requests total, coherence invalidations total, coherence timeouts total, and shared to modified transitions. Counters are 64-bit values that wrap at 264. Reading a counter does not clear its value. The coherence protocol operates continuously without pause. Processors may be in any of the 5 states at any time. State transitions are atomic from the perspective of the coherence system. No coherence operation fails permanently. Failed operations are retried. The system is designed to maximize throughput while maintaining strict consistency. All operations complete in finite time. The coherence system documentation concludes here.